Okay, so this is a linear regression problem with dealing with baseball, and it has to do with percent of strikeouts and I believe their batting average, or let me see here. Batting average and percent of strikeouts. So it's important to note that this y variable it's reported in percentages, but the x variable is a batting average, and it's in decimal format. And so these are percentages, and because we like to calculate in decimals and communicate in percentages, I've converted these to decimals. Okay, so that's the first thing that I did. And then the second thing I did was I entered the x into my list 1 in my calculator and my y into my list 2 in my calculator. Now again, you can do everything that we're going to do the old-fashioned way, using an adding machine, or just, I guess, your brain, but it's going to get really tedious and really complicated. So I recommend a calculator of some sort. So we're going to do it both ways. We're going to do the critical value method way, which is kind of the by hand method, and then I'm also going to be working the p-value method simultaneously. Okay? So we're trying to test the claim that the correlation coefficient is not equal to 0. So we assume that it is, meaning there is no correlation. So here it means no correlation. So that's always the assumption. That's always the H naught. There is no correlation. Versus the alternative, what you're trying to prove, or what you're hoping to prove, but often you can't, is that there is some sort of correlation. So we're doing a two-tailed test to see if indeed there is a correlation. When you're doing it by hand, the p-value method, you need a critical value, which is a t, with your alpha, your level of significance, and degrees of freedom n minus 2. Okay, so look on your t table and look up that value, and you should be seeing plus or minus 2.776. And in the critical value method, of course, you draw a picture of your rejection regions, and you label them minus 2.776 and positive 2.776. And then you do a test statistic, and you plug in your R value and your N value and your coefficient of determination value. Now, how you get these numbers is up to you. You can use their corresponding formulas, or you can have your calculator tell it to you. I'm going to bring up my calculator. I'm going to bring out the big gun, the TI-89 titanium, just to have variety. I try to mix up the calculator usage throughout the course and the videos to show you all the different calculators that are out there. Now, I've went ahead and I've entered my list, or my data into my list already. So I'm going to I'm trying to do a t-test, and I know that my t-test will bring up R values anyway, so that is an F6. And I'm going to go down to linreg t-test. It asks me, is your X list the correct one? Yes. Is your Y list this one, named this one? Yes, it is. Frequency's 1. I am doing a two-tailed test, and store the equation. Yeah, that's fine, whatever. Calculate. It's going to give me my test statistic for me if I didn't want to calculate it by hand, which is awesome. It gives me my p-value, which I'm going to write down in a minute. It also gives me my A and my B for my equational line. It gives me an S, which is the standard error of estimate. It gives me R squared, and it gives me R right there. So I can use all of those things if I'm doing it by hand. So our R value was negative 0.8913 with a float set to 4, and the coefficient of determination 0.7944 when your float's set to 4, and that gives us a test statistic of negative 3.9314, and I'm checking it with the one my calculator told me should be the value, and I have to scroll up to find it, and yes, that is matching very nicely. So indeed, we did that correctly. I'm going to write down the p-value, because if you're doing the p-value method, that's all you need is that p-value, which makes hypothesis testing go very quickly. If you're doing the p-value method, you just have to compare it to alpha, which in our alpha is 0.05. This p-value is less than, so we're going to reject based on the p-value. But if you're doing critical value method, you see that this value, negative 3.9, falls in your rejection region. So in that method, you also reject, and then you conclude based on the evidence there is a significant difference. That's old school. Significant correlation. I was thinking of testing with means. There is a significant correlation between batting average and percent of strikeouts at alpha equals 0.05. Okay, so we're testing for a correlation. We conclude that there is some sort of correlation going on. We're not sure what kind because we didn't really care about that. Now, if you wanted to do a prediction interval to go along with your hypothesis test, like this problem asks of us, is find and interpret an 80% confidence interval for y when x equals 0.300. This is a prediction interval, and this titanium can do one of those very easily. If you have it, you would just go to F7, and you would go down to lenreg_t_int, and you would pick, when it says interval, you would pick response. A prediction interval is also called a response interval a lot of times, and you would enter the value that they give you. X is 0.3000. And you just hit enter, and it's going to think about it for a minute, and then it'll bring up that interval. There it is. It gives you the interval, the cint, right there. Okay, so you just get to write it down. It's that awesome. If you're doing it by hand, or maybe your calculator doesn't have a response interval or a prediction interval, you got to calculate the standard error of estimate first, which is very annoying because it's kind of an icky formula, but it can be done. It's just, you know, kind of icky. So plug in all of your summary statistics and your A and your B and all that good stuff. I'm not going to go through and do it for you because by now you should be fairly good at manipulating formulas and very comfortable in it, so you don't need me to walk you through it. You're grown-ups now, right? You can do it on your own. I will share with you the answer. Standard error of estimate should be coming out to about 0.016838. And then when we're doing things by hand, we want to then calculate the error of tolerance, also called the error of estimate, also called a margin of error. You want a t confidence value. You should be doing a t of 1.533 there. Standard error of estimate, this guy right here, insert that, times the square root of 1 plus 1 over n times the x they gave you, minus the sample mean, parentheses squared, all over n times the sum of the x squareds minus the sum of the x's, and then you square it. And you get all that, and you work all that out, and it's a doozy, I'm not going to lie to you. Don't try to do it in this amount of space. Definitely use your own scrap paper or multiple pages. You should be getting 0.027938 or something very, very close. Again, you understand rounding error and all of that by now. There's a note here. On our third step, we got to actually determine the interval. We need a y-hat. So you have to find your predictor value, your y-hat, when x is 0.3. You use this equation, you plug everything in, that's your y-hat. So you're doing y-hat minus the e, and then y-hat plus the e. You're getting an interval, or should be, if you're going to round to 4 decimal places, 0.0393, less than y, less than 0.0951. That's your interval, and if we look on our calculator, we're getting an interval very, very close to what they're getting. Of course, my interval will be a little more accurate in my calculator. It's always very hard to read because these guys are so incredibly small. It's always just very difficult to read. But this is what we're getting, and then we want to do our interpretation based on the evidence. We're 80% confident that the true population mean percent strikeouts for when X, the batting average, is 0.300, lies in the interval. I'm going to convert these back to percentages now, so that would be about 3.9% to 9.5%. Yeah, and that's your interpretation of the confidence interval. And again, you're going to need a lot of paper if you do this by hand, but if your calculator has a response or a prediction interval, then you should be okay. So good luck with that. And then the next thing that we're going to do is going to be a beta test with a beta interval to go along with this baseball problem. So stay tuned for that.